So for experiment 3, we actually studied transfer functions and time response of first and second order systems. And here I'll briefly show my outputs and what I did and make key observations. And so what I did was I first derived the transfer function from the given differential equation. And after applying Laplace, Laplace transform, I got Ts is equals to 100 over s squared plus 4s plus 100. And then I verified using MATLAB by defining n is equals to 100 and d is equals to 1, 4, and 100. The results actually matched my manual solution, confirming that my transfer function is correct. So for the step response and inverse Laplace for page 2 and 3, our unit step is I multiplied the transfer function with rs is equals to 1 over s to get ys. And then I manually solved the inverse Laplace and obtained the time domain response. 1 minus e raised to the power of negative 2t cosine 9.798t plus 0.204 sine 9.798t. And also use MATLAB to verify this using Laplace function, and both results actually matched. So I plotted the step response from t is equals to 0 to 3. The graph actually showed an underdamped response with oscillations before stabilizing. And for the graph, I estimated around 2 seconds, and rise time is 0.2 to 0.3 seconds, peak time is 0.32 seconds, and the overshoot is actually 50%. And so, next is the first order systems. For the first order system, I analyzed the transfer function and found out what response was actually exponential and composed of a forced response, which is the steady state, and the natural response, which is a decaying exponential. This actually confirms how a first order system smoothly approaches the steady state with oscillations. And for the second order systems, I analyzed the different second order systems, which is the 4 cases. Class A is the overdamped, Class B is the underdamped, and Class C is underdamped continuous, and Class D is actually critically overdamped. And by checking the roots or poles, I actually determined the behavior of each system. The challenges here is actually one, solving the inverse Laplace manually, because especially the partial fractions, like I had to relearn everything. Also the part where I actually had to understand how poles affect the system behavior, and it took a lot of time. And the important takeaway for self is the poles determine systems, the system response, and MATLAB is used and very useful for verification. And I must also always check if the results match manually and computationally. Thank you.